part 2 video for 4-4, adding and subtracting rational expressions. We're going to pick up with example 4. We've looked at addition already. Now we're going to look at subtraction because it says here, what is the difference between these two rationals? So I have a subtraction in the middle. I do have to go through, just like in the last one, and factor my denominators and figure out what my least common denominator is going to be. So this is x plus 1 over, this is going to factor into x minus 8, x plus 2, and then I'm subtracting from that my second fraction, which has x plus 1 on the top, x plus 4, x plus 2. So my least common denominator, again, has to include every factor. Well, I have an x minus 8, an x plus 2, and an x plus 4. So all of those have to be present. My first fraction is missing the x plus 4, so I have to multiply again top and bottom by that x plus 4. Second fraction is missing the x minus 8, so we have to multiply by that. So just like in the last example in the last video, I do have to FOIL on top. So when I FOIL the top of this first fraction, I'm going to get x squared plus 5x plus 4, and again I'm subtracting. Second fraction, and I am going to rewrite this to be in the same order. Multiplication is commutative, so you can switch the order that you multiply in. A times b and b times a are the same thing, so I am allowed to rewrite those. Then when I FOIL the top, I'm going to get x squared minus 7x minus 8. Now here's where this type of question can get tricky. Of course, my denominator is not going to change. At least not yet. And I'm going to write this all out. X squared plus 5x plus 4. We are subtracting the entire second fraction. So you are subtracting the entire numerator from the first numerator. That means that every term in that numerator has to change sign. You're not just subtracting the x squared and keeping the other ones the same. The x squared is going to turn into a minus. The negative 7x, though, is going to turn into a plus because it's minus negative 7x, and minus negative 8 is going to turn into a plus 8. So with this one, and with any subtraction question, usually the mistakes that I see are students not carrying the subtraction through the entire second numerator. They only do it to the first term and ignore the rest. So please, please be careful of that. When you combine like terms, then your x squareds actually add out. And we're left with 12x plus 12 over, again, my denominator, x minus 8, x plus 2, x plus 4. On top, there is a greatest common factor, so I can factor 12 out of that. So I have 12 times x plus 1 over x minus 8, x plus 2, x plus 4. And even though we were able to factor the numerator, there is no 12 as a factor in the denominator, nor is there an x plus 1 as a factor in the denominator. So I can't do anything else with this. This would be my solution. That would be my final answer. The next one that we're going to look at is a word problem. And these sometimes appear on standardized tests, so I wanted to make sure that I went through and did this type of problem. So we have Leah drives her car to the mechanic. She takes the commuter rail train back to her neighborhood. The average speed for the 10-mile trip is 15 miles per hour faster on the train. Find an expression for Leah's total travel time. And then it says if she drove 30 miles per hour, how long did this take? So we have two things. We have to come up with an expression, and then we need to figure out how long this total trip took. So we need to figure out the total time. Well, if you recall, from other information that has been given. Distance is going to equal let's make sure we get this set up correctly. Distance is equal to rate times time. And that means if I'm finding my time, that is going to be distance divided by rate. So rate is going to be time is going to be distance divided by rate. And in looking at this, for some reason this is written incorrectly on the PDF with the little equations, so you're gonna have to make sure that you go through and scratch that part out. The actual work is correct, but the little D and R's and T's, those aren't necessarily set up correctly. I'm not quite sure what happened with that. So if I find expressions for my time, the car, if it traveled a distance of 10 miles at a rate of R, my time is going to be 10 divided by R. The commuter rail traveled the same distance, but its rate was R plus 15, so that's going to be 10 over R plus 15. The total time would be 10 over R plus 10 over R plus 15. Total means I need to add those together. We do have to find an expression, so I can't plug in the 30 for the R yet. I have to wait until I get down to my, my final combined expression. So my least common denominator has to include every factor. So that's going to be R and R plus 15. Again, the R plus 15, you cannot separate those out. That R is attached to the 15, so just because it happens to have an R in it, the R is not a factor yet for the second fraction, so keep that in mind. So the first fraction is missing the R plus 15. The second fraction is missing the R. So my common denominator is going to be R times R plus 15. On top of the first one, I'm going to have 10R plus 150. Second fraction, again, has the same denominator. On top, I'm going to get a 10R. When I combine those together, I'm going to get 20R plus 150 over R times R plus 15. So that's my expression. That's half of my answer. Now, if R is equal to 30, then I can replace the R's in that with 30. So I'm going to have 20 times 30 plus 15 all over 30 times 30 plus 15. Whenever you do the math on that, you're going to get 750 divided by 1350, which is 5/9 when you simplify it, and this would be 5/9 of an hour, which is about 33 minutes. So this whole trip took her about 33 minutes to complete. Again, make sure you know these, fix them on the notes if you're copying down notes from the PDF, because for some reason those formulas are not correct on there. The last thing that we're going to look at is compound fractions. These are fractions within fractions. So it's a fraction that has one or more fractions in the numerator and or denominator, and there's two different ways you can deal with this. We're going to look at method 1 first, which is where you find the least common multiple of the fractions in the numerator and denominator, and then multiply the numerator and the denominator by that least common multiple. Basically, you're taking it, instead of it being fraction divided by fraction, you're going to have polynomial over polynomial. So if I look at this first method, my least common multiple, luckily for everything is factored, I want to look at all the denominators in the top and the denominators in the bottom. So I have an x plus 1, and I have a y. So all of those are going to be multiplied together. So I'm going to take my fraction and multiply the top by x times x plus 1 times y, and I'm multiplying the bottom times x plus 1 times y. So you do for this, unfortunately, have to combine what you're really distributing. So you don't necessarily have to combine them together yet, but you do have to distribute what you have. So for the first one, you see here, if I take this whole thing and multiply it by the 1 over x, the x's are going to divide out, and I'm going to be left with x plus 1 times y. So that's multiplying this whole term by that. And then I multiply it by the second fraction. So when I multiply it by the second fraction, the x plus 1s are going to disappear, and I'm left with 2 times x times y. When I multiply this whole thing by the denominator, which is 1 over y, the y's are going to divide out, and I'm left with x times x plus 1. So when we go through and simplify this, I do have to distribute. I get xy plus y plus 2xy all over x squared plus x. If you want to distribute that, you could leave it x times x plus 1. Maybe I'll do that instead. And then on top, xy plus 2xy is 3xy plus y over x times x plus 1. So that's that method. This is not my favorite method for combining, but it is useful. It does work, and it gets rid of the fractions quicker, and so you just have one fraction instead of fractions within fractions. Method 2 is what I prefer, and actually I already have a work here for method 2, so I'm just going to leave it. So method 2 is where you express your numerator and denominator as single fractions, and then multiply the numerator by the reciprocal of the denominator. So basically, you're going to treat the numerator and denominator as separate questions. So I would look at what my least common denominator is of the numerator, which is x times x plus 1. You can see the first fraction here was missing the x plus 1, so I multiplied on top and bottom. Second fraction was missing the x, so I multiplied on top and bottom. And then I have x plus 1 over x times x plus 1 plus 2x over x times x plus 1. And then the denominator, the 1 over y, it's a single fraction, so there's nothing to combine. But normally you would have to look at what the least common denominator is of the denominator fractions as well. So now I'm going to combine the tops, and I can highlight on here so you can see what I did. So I'm going to combine those two together. X plus 1 plus 2x is going to give me the 3x plus 1. And then my denominator, those two denominators, that's just going to stay the x times x plus 1. Now the rule with fractions, whenever you divide a fraction, so we're dividing the fraction of 1 over y, that's the same thing as multiplying by the reciprocal. Well, the reciprocal there is y over 1 instead of 1 over y. And then you can multiply the tops, multiply the bottoms. That's how we have y times 3x plus 1, which is the same thing we got in the previous question. I just didn't factor the y out. And then x times x plus 1 is the denominator. I prefer method 2 when going through and solving compound fractions. If you take calculus, you will see this whenever we are finding derivatives involving functions that are rational. So this is something that will come up again if you continue through higher math classes. We aren't going to focus on it a whole lot in here, but you can expect to see maybe a question or two on your next test. So go back through, rewatch this video, and reach out to me if you have any questions at all.